Hi, and welcome to Tremco Live, where we're socially distant but technically connected. I am Marcy Tyler, the Director of Building Science for Tremco, and I am one of your hosts. Our other host is typically Paul Hugenboom, and he is not able to join us today. He is once again on the road. We're excited about the content we're going to be able to share with you in July that is all about being on the road and hanging out with all of you. So until then, we're focusing on testing in the month of June. If you didn't catch our broadcast last week, Paul and I took you on a tour through our facility. These are tours that we give on a regular basis. So if you're ever interested in that, I'm going to share with you that information. But testing, as we know, is so important and so critical for our projects to be successful and to meet those performance criteria. So I'm doing a shout out right now to all of you watching today, is if you have testing that you do on a regular basis, if there's testing that you want to share, please do that. I'm also looking at setting up a debate on the last Friday of the month where we're going to talk all about something that I find very exciting related to testing, and it has to do with facade anchors. So once again, if this is ringing true to you as something of interest, please let me know. As always, we are excited and appreciative of the opportunity to wind down with you on Friday and be able to talk through things that are top of mind. As I mentioned, this entire month, we're going to focus on testing. So let's take a look at a couple slides as it relates to testing. So Paul, when he's usually here, he talks about the Tremco CPG and all the different companies that we get to represent. So it's the systems, the products, but he always likes to mention, most important, the people. And that includes all of you that are watching today as well. So I can't give out that shout out more, but I'm going to, is if there's ever anything you guys want to share, anything that you feel is of interest, relevant in the industry, please let me know, and we would love to be able to feature it on our live broadcast. So I mentioned that last week, Paul and I took you through a tour through our test facility. This has become such an important part of what we do and who we are. We really feel that it is so critical to be able to look at how these connections work. And to be able to do that, we've had some evolution in our testing capabilities. Now, this is our assembly testing. So obviously, there's a lot we do from an R&D perspective at that material level. There's a lot that goes into different types of exposure testing that we do at different farms across the country. And of course, we always collaborate with a lot of different testing agencies when we're getting out these products out into the field, and of course, field mock-ups. Specifically, what we looked at last week was just kind of walking through some of the things that we can do together as it relates to testing in the industry. So I just wanted to highlight that again briefly here. We started off doing air and water, or doing air leakage testing. We knew that we wanted to be able to test for water as well. So we wanted to be able to broaden that capability and add that access to that type of testing. We also wanted to go bigger. So in 2015, we expanded that testing. And then, of course, just recently in 2020, we added that thermal chamber. So I am really hoping that this is going to get to the point where it really intrigues you, where you want to either attend virtually or there is some testing that you want to do with us. We definitely want that capability to be able to do that with you. We've got lots of different information that we can share as it relates to past testing, but we really want to think about those design challenges that maybe keep you up at night. Things that we can work on, collaborate together, and put a whole project team together that will include the contractor, the general contractor, the owner and the developer, and of course, the consultant. And then we can always bring in that third-party testing agency to help us validate our equipment, validate that testing. So keep that in mind. And as well, if there's the need to have a tour, you can just reach out to me. The tour is going to walk you through all that capability. We're going to talk about specific case studies of different types of assemblies. And at the same time, we've set it up so that you can get AIA credit as well as the IIBEC credit as well. So it's given in a really thought leadership, informative way, and it really starts to have us lending towards that path of trying to really understand the impact of choosing different technologies, the impact of whether or not we're going to use threaded fasteners or maybe we're going to adhesively attach facades. It's really going to have us thinking about the impact of using different types of fasteners and what that means from a thermal resistance. So please join us as we take that venture one step further throughout the summer and, of course, throughout this year. If there's things that you'd like to take a look at, please reach out to me. If you noticed on LinkedIn today, I did post that we wanted to focus on field testing today specifically, and we listed a couple different AMA specifications. So I thought what better way to do that than to invite one of my good friends in the industry to come on and join me. So Adam, welcome to Tremco Live. Adam, thank you so much for being able to join us again for Tremco Live. We're pretty excited about you coming on and talking to us about specifically these field tests. So why don't you give me a little input and let everyone know your experience in the industry.
Sure. Yeah, so I'm regional manager for Building Science Solutions Group for Intertek. So I cover sort of the Mid-Atlantic region into Pennsylvania, actually all the way down to Richmond now. But we work on, I would say, mostly new construction projects, and we do some failure investigations as well. But a lot of third-party consulting for contractors, and also a lot of building enclosure commissioning for owners as well. So, and we do some work for architects, but all the same type of work where we're reviewing drawings and coordinating trades, and then also, one of our biggest features, I guess, as being Intertek, is I have access to all the field testing right at my fingertips. So a lot of the testing that you mentioned that we're going to talk about today, we use it on pretty much every project. So AMA 502 is sort of a guideline for two tests, the ASTM 1105 and 783 air and water tests. And AMA 501.1, the dynamic test, we'll also talk about today, and nozzle testing. So those, yeah, I mean, it's so critical when we're, on a project, we're consulting on a project, or even if, we don't have the opportunity to consult on a project and we're just sort of advising on testing. It is critical to making sure, you got everything air and water tight. It's such an easy thing to do before you get the building done and you have a problem. So, yeah, look forward to, I've been doing this for close to a decade now, and have a lot of experience both doing the testing and then also witnessing and specifying it. So I've definitely got a lot of experience with it. So any questions anybody have, I should be able to answer them. If not, I'll find out an answer for you.
Exactly. If we don't know it, we'll get back to them. So I know there's a big focus, obviously, at Intertek with testing. I know you mentioned a lot of different services. So I just put this up here as something to kind of kick off our conversation as we take a deeper dive into some specifically. But do you want to talk a little bit about that building and construction standards that you guys have available to the industry?
Yeah, I mean, Intertek's, we go even beyond building and construction, but I mean, anything that you can test, we pretty much test as far as a product. My group, building and construction, certainly focuses on buildings, and we get into some transportation projects, but mostly building and construction of buildings. So any type of testing, concrete testing, geotechnical testing, we're there on the front end, and then more of the stuff that I do is on the architectural side of things. But we get involved with laboratory testing of all these types of products, as well as the construction side, where we're testing and evaluating the materials and assemblies in the field as well. So yeah, I mean, anything that is on the building, we can probably test or inspect it. So, and consult on it. A wide range of consulting, from enclosure like I do, to fire protection, to acoustics, advanced geo, lots of different services and ways to help you with your project. So.
And I was doing a little research, prior to you coming on today, and I was curious as to how long ago you guys combined with ATI, and it looks like it was about 6 years ago.
Yeah. Yep. I can't believe it's been that long. Yeah, I actually started with ATI, and then it was about a few years in when Intertek acquired us. So yeah, Yeah, the ATI is sort of each year it drifts away a little bit more, which is
Yeah.
crazy. In the beginning we had a lot more pride to keep that name, but we've all kind of melded to one, which is the idea. So
Yeah. I actually found some test reports. I've got one that we're going to share that has the ATI logo on it. So that's what made me curious as to how long ago that happened.
yeah,
So let's, why don't we take a dive into it? So I mentioned, and you did as well, that we're going to talk about a few of these AMA tests, and this one in particular is AMA 501.1. Tell us a little bit about this test.
yeah. So most of the glazing systems that you see, storefront, curtain wall, they go through a series of laboratory tests before they ever go out in the field. So that would be the product testing side. One of those is a dynamic test. If you've seen any pictures of ATI or any lab that does architectural testing, you'll see the big propeller. It's like an airplane engine and a big,
Yeah.
cloud of water spray. So this is the field version that we developed, I think, about 10 years ago, and it's essentially the field version of that dynamic test that we do in the lab. But basically, it's a fan that creates a wind-driven rain. We have a spray rack mounted to that fan assembly, and it's calibrated. We can basically set it up, and we can determine how much pressure it's exerting on the building, and that certainly correlates to a certain wind speed. So any test pressure that you need to hit, we can adjust the RPM of that, or anybody who has a rig like that. There's other companies that have that assembly as well now, but basically you adjust the speed of the fan, and you can adjust it to the specific test pressure for your project. But it's a great test. It's counterpart the ASTM 1105 static test, where you have to build chambers on the inside. It's a lot more. You can test a lot more areas of the building, and you don't have that restriction of having to build a chamber to create a pressure difference. So you can test the wall, the window, and the roof interface in one shot. If you had to do that with a chamber, it'd be really, really complicated on the inside of the building, getting around studs and different things. So I use this test a lot. Yeah, sorry, Marcy.
No, I was going to say I have some videos of
Okay.
when we were with you of just doing just that. We did it one area and then we moved it over, so it is pretty convenient to be able to do that. So this is a pretty common test then. So this is a test you guys do very often.
Yeah, I mean, it's now that it's been around for close to a decade or over a decade. Not only are we performing it, but there's many other companies that are performing this test, and it's definitely not something new. It might be new to a certain project, but it's been used for a long time now. So.
And you mentioned you can adjust obviously the wind speeds. Depending on what is in the specification. Is there a set time frame that you usually run it for?
Yeah,
or
so
is
this
that
test,
specified as well?
That's part of AMA 501.1, so the standard that it's all in that standard, but it's a 15-minute test.
Okay.
Yeah.
So nice and quick. Okay, so I have a couple other pictures here, so we'll just kind of take a look at them. I know these are great different viewpoints, right? So you've got people on the outside making sure that we've got the right distance. You've got the spray coming down, and then obviously we're on the inside as well, taking a look at what's going on.
Right. Yeah, the distance from the specimens is critical. Anytime you're out watching any of these water tests, you want to, just double check that the testing agency is spacing it properly, because those nozzles are designed, depending on what one you use, it's supposed to deliver a certain amount of water at a certain rate, and and that distance will impact that. So, but yeah, he was measuring there the distance to make sure we were doing that properly. But yeah, and another great thing about the dynamic on the inside, you can see we're right up close to the specimen on the inside. There's no chamber in the way to really get in the way of our observations. So it's just it's so much easier to spot problems that way. But we were able to look at the wall below the window and So all the penetrations through the air barrier and different things we were able to observe also simultaneously.
Yeah, because I know we were on the inside looking at, like, obviously the penetrations, as you mentioned, around the window, rough opening, and of course the facade anchors. This is, I turned the sound off, so no one has to hear that, and this might be a little janky here as we watch it, but you know, just a quick little video showing it in action, of being in front of the window. And then we just regrouped and went ahead and went over to the wall area and did the same thing. It's always interesting when you're trying to capture this in a video. So if you look at them online, the fan always seems to go much slower than it actually is in person. So it's a little trick it plays on you. So this next one here is a test. This is what I was mentioning to you, is where I pulled this out of our archives for one of our products that we had and tested at ATI. And this is when we wanted to test that window to wall interface. And what I like is that we worked with you guys to kind of obviously set up the specimen. We wanted to do the water penetration test, the dynamic water penetration test, but we are also doing a structural load as well, where we were going to be able to move that entire window assembly a certain amount of inches to be able to show movement at the same time. So this is something that we did many years ago with you. But I found that in our archives, so it's very cool. This next one is AMA 501.2. So tell me a little bit of the difference between this one versus obviously the fan test.
Yeah. So the nozzle, we call this the nozzle test, but you're not really creating a wind-driven rain in this test. You use a certain nozzle, and then the water pressure is at I think it's between 25 and 30 psi, and basically you spray joints around a glazing system, and you can use it for diagnostics of other parts of the building as well. But basically you're spraying a certain area of the building, 1 minute per foot, sorry. And that's basically the test standard. You just look on the inside for water. It's great for diagnosing perimeter joint issues. It's when it comes to drainage glazing assemblies, so like a pressure wall system or a storefront, this test method's not the best one to use to evaluate a glazing system in the field, other than the perimeter joint, in my opinion, because you're only spraying an area for a short period of time. You can't get those inner drainage cavities wet. So great for transitions between different systems on the enclosure, where you can see exactly on the inside opposite of the joint that you have a clear path to where the hole is. Very good for that. So we use this a lot for interface testing and for different enclosure assemblies. So
that's a great point to bring up. So this is a good, maybe a spot check kind of test versus the 501.1, which is going to get you about 8 inches of water per hour is what that is intended to do, so that you've got a good film of water down that face, putting that pressure on it with the wind, and then really being able to highlight where those problems could be. Right. This is just a little shout out to Matt Stepanian with J.E. Dunn, who was able to provide me a few pictures of when he was performing this. So he likes to do this test on mock-ups, just so he can get a line of sight as to where there might be some issues. Just like you mentioned around the transition. Yeah, exactly.
Yeah, I think that, sorry, I spoke wrong. I believe the water pressure is 30 to 35 psi. I apologize if you're fact checking.
Well, you know what? That always happens, right? People love to do that. We should do a whole one where we're saying different things and see how many times people can correct us, because I love that. People help out in real time. And then we also wanted to go into the AMA 502. So just looking on the information that you guys have, you do have a great information sheet. I guess there's been an update to this AMA 502 from 12 to 21. So there's some great information that you guys provided there. And I know it incorporates a couple different tests. Tell us a little bit more about this one.
Yeah, so this is the key to remember is that, everything AMA related is voluntary. So when you specify on a project, this is just helping the designer or the project team understand how to use these test methods. So AMA 502 really just outlines how to perform ASTM E1105 and ASTM E783. ASTM E783 is an air leakage test, field air leakage test. ASTM E1105 is a static water penetration test. So it just goes through the procedures in there. It also discusses what the failure criteria is for the test, as far as what water leakage is. The other big one, this is one that it comes up quite a bit, is the reductions, the field reduction. So back to that laboratory testing that we mentioned before, there's a certain pressure that every system gets tested to in a lab, and that pressure is usually higher than what it gets tested in the field. And the reason is because AMA basically they decided that it's reasonable to assume that you could reduce the pressure in the field because of field conditions, and you're not going to get everything perfect. So there should be some expectation that you're not going to have the same performance that you would have in a laboratory. So it outlines that how that's done and how to do the reductions, and that's basically the gist of AMA 502. So it just helps really guide everyone how to use those two test standards. But it is voluntary. So, a lot of the time you get on projects and you might have a consultant like me that doesn't want to do the reduction for some reason. Maybe you're next to the ocean and there's always high wind speeds and you want to test the full pressure. You may not use that reduction. The AMA 502 document allows for the design team to decide, or the designer or the specifier to determine whether it's needed for the project or not. So
okay, that's helpful for me. I didn't realize that.
Yeah,
I also
it's
included
a contention for sure on jobs.
I bet it is. I bet it is. I included this interface guideline that you worked on because you are on the board of directors for ABAA. So I found this as well. This ABA article that you put together, and I know it includes a lot of great information about interfaces. I know you worked on this with the committee, and it does include some of that testing. Tell us a little bit more about this document.
Yeah, I appreciate you throwing putting this in there. I know it's on the ABO website, but I don't know how easy it is to get to it. But yeah, so
we'll share it with everybody too.
Awesome. Yeah. So
yeah.
I'm the task group chair for the transition terminations and flashings task group, and part of ABA's initiative now is to really expand beyond air barriers and really talk about the interfaces and how really what whole building air tightness is and also controlling water as well. So in my task group, we're pushing to try to show how the air barrier connects to all the other systems. And one initiative was to start developing these white papers on different glazing systems. So the first one was curtain wall systems and how they're interfaced and how to make sure you're getting an air and water tight connection, how that impacts thermal performance. So in that document, it has a general overview of what a curtain wall system is and the different types, and then how to interface it with the air barrier. And then certainly at the end, it talks about how to test it, how we test it in the lab, how we test it in the field to make sure that we have the performance that we're looking for. So the one thing, yeah.
I found it super helpful. So we'll definitely share it. We'll definitely post this up. But there's a lot of great information in there. As we know, most of your issues are going to happen at those transitions, right? So this is a great, super helpful document to help, remedy those situations from happening.
Yeah, that figure on the front, the first page there is a great example. They, in that particular case, they never connected the air barrier to the curtain wall. and it leaked. So, it's not hard to determine why that happened once you look at that section detail. But yeah, it just the interface and how that all ties together. Testing is such a great way to really focus on those. They're the first things that's going to leak when you do a test. So it's a great check for that. Not just the system that you're testing, but also the interface. So
I know I've been on a couple mock-ups, fortunately, where we could put our hand from the outside to the inside. So like in that drawing, things weren't connected appropriately. Do you have a story you can tell us maybe about the most interesting test you've ever run or interesting discovery you've had to put you on the spot?
That I uncovered during testing. I mean, there's a lot where I've been called in for water leakage investigations where, water's coming in the head of the window and they blame the window. And this one particular project, it was actually the parapet that was leaking, but we had to work our way up the entire building. And what had happened was they had a capstone on the top of the wall that had a mortar joint, and the roof never tied into the wall air barrier. So basically water absorbed through the mortar joint, it got in, and because they didn't have the window interface properly, it went right into the head of the window and leaked in. So that was a cool one because I was there for 3 days and it was the last thing I tested to determine. I'm trying to think of a new construction one that usually with new construction, you know what, you have such a clear line of sight to what the interface is that it's not
right, because you've been a part of it. You've been a part of it. You know what materials are being utilized and where, so it makes it a little easier, I'm sure, to find it.
I wish I had a better one.
I know we've had. So no, I think that's a good one, because I think what I'm talking about too is just how the leaks may end up in a spot that it didn't originate from, right? So that's that whole investigative process of going back in to try to figure out where it actually came from. I know we've had some situations where, imagine a 40-story building, lots of glass and glazing, and that leak can transfer and travel a lot and may not, show up anywhere close to where it's coming in at. So it certainly keeps us all on our toes.
Right.
But it also lends us back to making sure that we do everything we can ahead of time, right? Communication of that whole design team, doing stuff in the lab, and then obviously mock-ups, and then onto the job site so that we can test things throughout that whole process. So thank you, Adam, for being on today. I really appreciate it, telling everybody about this field testing. I know there's a lot more that we could share, so I'll be checking in with you again soon, and maybe have you again on a future program. I'd love to do one live, actually feature some testing, so that's something we can coordinate as well.
Okay. Yeah. I'll keep that in mind to see. I know we've got some more projects with Tremco stuff too, specifically. So we'll try
some of the conversations we've had, I would love to capture that. Some of these different tests, comparing different types of tests, and what do those results look like. So
okay.
We will definitely catch up with you on that. So, okay, well, thank you so much for joining us today. Thank you, everybody, for tuning in. Hope everyone has a great weekend and have a safe time. Thanks, everybody.
Thanks, Marcy.
Thanks, Adam.